can kind of work through these things. So your test is extremely similar to this study guide, which they always are, but maybe even more so than usual. So the first few questions on your study guide, we asked if, so the mean outstanding credit card debt was $3,173 in 2010. A researcher believes the amount has decreased. So your null, correct notation. So on your null you have the h sub 0. We're talking about the mean. The null is always equal. Your alternative, we said decrease, so the mean is less than. All right, so part B, a type 1 error. So the error is what we've kind of struggled with interpreting. Remember, type 1 means you conclude the H1. The ones go together. But it's an error. So it would be like the researcher concludes the mean has decreased. But it has not. Okay, so when you are telling me these interpretations, you have to tell me basically which one they concluded, and you have to throw in there, but they're wrong. Okay, so we made that mistake. So type 2 error. If type 1 concludes H1, type 2, you would conclude the null. So the researcher concludes the mean is the 3,173, but they're wrong. They should have went with the alternative. So it has decreased. Do we understand what those things mean? All right, so D. State the conclusion if the null is not rejected. So I am going to be pretty picky on these. What we are doing in hypothesis testing is we're basically saying if the null hypothesis is true, what is the probability that the alternative happens? So are we ever actually trying to prove the null? No, we are making the assumption that it is. So at the end, you can never say we prove the null hypothesis is true. That's not the case. We either have enough evidence to believe the alternative is true, or we can't prove the alternative. We're never actually proving the null. So this one we were saying the null is not rejected. So we would say there is not enough evidence to conclude the mean is less than $3,173. Okay, so if we cannot reject the null, there is not enough evidence to basically conclude the alternative. All right. So part E, if the null is rejected, that means we didn't, or that we found enough evidence to believe that the alternative is true. So there is enough evidence to conclude the mean is less than 3173. Are you guys okay with that? So, first question on your test tomorrow will be like this. Although the one on your test doesn't have quite as many parts. handle that. You know what type 1, type 2 errors are. You know how to write your conclusion. All right, question number 2. So the proportion of individuals who cover their mouth when sneezing, this is really disgusting, is only 73.3%. A student believes the proportion is different. So, the null. We are talking about proportion here. So, the null hypothesis is that the proportion equals 0.733. You guys all know why it's a proportion and not a mean. Okay. Then the alternative, we believe it's different. So we'd say not equal to. All right. So part B. You have to know your criteria. So make yourself some notes. If I'm talking about the proportion, what is basically the one criteria that I really need to see you check? Okay, and if we are talking about the mean, what is the one criteria I really want to see you check? N is greater than equal to 30. Or the original data has to be normal. All right, so those will be questions. You guys act like it's really 30 questions. We check criteria all the time. I just asked it as a separate piece. So you know which criteria go with which variable. Should be easy points there. So you verify that. So our N, we're looking at 100. Our P, 0.733. 1 minus 0.733 is 19.577. So greater than 10. We're good. Part C. All right, I asked you to do this one by hand. So on your test, I think I asked for you to do 2 things by hand. So you can probably assume one of them will involve a T and one of them would involve a P. Have you do one of each by hand, then we'll do the rest on the calculator. If I am talking about a P, am I looking for a T or a Z? Okay. So we need our P hat when we do this. So P hat is X over N, where we looked at 78 out of 100. So our Z-score is P hat, or our value, minus the P of the null, divided by the square root of And do you guys know where this is on your formula sheet? That's really what it comes down to. You don't have to necessarily have it memorized. You just have to know where to find it. If you're looking under chapter 10, our test statistics, we have a Z and we have a T. So we are looking at the Z one here. And we know that because the Z formula has our proportions in it. If you try to do a T, it's asking for the mean, and we don't have that stuff. Okay? So, if we do that calculation, we get 1.06. Is everybody with me here? At this point, we have different ways of finding it. We talked about like the classical versus the p-value approach. So if I looked at this, the one thing that kind of throws us off here is we are testing not equal. So this is a two-tailed test. We need to find this probability. So if you go to your Z table, it's our normal table, and if we look up 1.06, we have to kind of understand what that means. Normally we're just looking at less than or greater than, and it's a little bit easier. In a two-tailed test, this is 1.06, but we also have to consider the other tail. And again, that's only because the alternative was not equal. So essentially, we need both of these probabilities. Now they should be the same, right? So if I find one of them, I could just add them together. Which one would be easier to look up? 1.06 or negative 1.06? Probably the negative, since our table gives us the less than. So if we look up the probability for negative 1.06, we get 0.1446. And we know we have two of those because of the two tails. So our probability is 0.2892. Okay, so we found our z. Normally, you would just look up your z. If your alternative is less than, you just look up that number. If it's greater than, you do 1 minus the probability. Because it was a two-tailed, we had to take it times 2 here. And then we have to make a conclusion. So, the nice thing about doing the p-value approach is we interpret it the same every time. If p is less than alpha, we reject. Here, our alpha was 0.15, so since p is greater than alpha, we fail to reject. There was not enough evidence to conclude that the proportion was different. Does that mean we proved the proportion was 0.733? No, it just means we didn't prove it's not. Everybody okay with that? And you know what you would do differently if I asked for a less than or a greater than? Okay. Number 3. So we have a professor recommends his students spend 480 minutes outside of class studying each week. The number of minutes each student in class spent on doing online assignments is recorded. Assume the data is normal. So do we have to have all 30? No. All right, we want to know if it suggests students are studying less than the recommended level. So what would my null be?
X bar equals 480.
We usually just do mu. X bar just means mean of the sample, but we usually just use this variable. Then the alternative, we want to see if they are studying less. And so this one, I did not say you had to do it by hand, so we would go to our calculator, stat, edit, and we are going to put all of this in my L1. And then we go to stat, calculate. All right, what should we look at here? If we are talking about a mean, are we looking for a Z or a T? A T. Do we have 1 or 2 samples? 1. So we just need our t-test, number 2. We're basing it off the data because we entered it. The mean of the null was 480. List should be L1. We are testing less than. Okay, and then what work do I want you to show me when you jot this down? Yeah, I would like for you to write down your T and your P. And then we have to make a conclusion. Did I enter something wrong?
No, 54 instead of 504.
Oh, you didn't say anything sooner. Come on. All right, so assuming that I had actually entered all my data right. And that's why you should take a minute and look back over and make sure you entered all your data correctly. All right, is that better? So we write down our t and p values, and then your conclusion, our alpha was 0.05, so since p is greater than alpha, fail to reject. All right, number 4. We want to determine if the mean, so we know we're talking about mu as our variable, is more than 100. So the null would be equal to 100, alternative would be greater than 100. Condition, if we're talking about the mean, our condition has to be bigger than 30. We have a sample of 35. So 35 is bigger than 30, so we're good. Part C, test it by hand. So we've already done one involving a z. Now, if we're talking about the mean, we have to find our t value, right? If you forget, you just go to your chapter 10, look at your formula. If we're talking about mean, the formula that involves it is t. So to calculate our t, it's the mean of our sample, which was 104.3, minus the mean of the null hypothesis, which is 100, divided by standard deviation of our sample, 12.4, over the square root of n, which we had 35. If you do that, you should get 2.05. Okay, I want everybody to look at this. The t one is a little bit different, so get out your t distribution. All right. So, what we know, how many, we have our t-value, we need to know our degrees of freedom if we're going to use this table. How many degrees of freedom would we have? 34. It's n minus 1. So you go down to your 34 row. You go over until we get as close to 2.05 as we can. So that would be 2.032. And then you go up, the top has the probability. So what is the probability of that one? Does everybody know how to read that from your table? Okay. If you do it on the calculator, are you going to get the same probability? No, this table is very limited, which is why we didn't do these by hand very often. So I have my probability. Now we need a conclusion. We were at the 0.05 level. So P is less than alpha, which means we reject. If I ask for a sentence, that means we have enough evidence to conclude that the mean is more than 100 now. All right. So could you guys do these by hand? Number 5. All right, golf balls are required to have a diameter of 1.68 inches. A random sample of golf balls was collected, the diameters were recorded. Assume the data is normal, so I don't have to worry about my criteria. We need a 95% confidence interval to determine if the balls meet the standards. So what would the null hypothesis be? So then the alternative would be, okay, so if you want to do this, let's practice since we haven't done it since last week. We go into our data, we enter everything in L1. Hopefully I entered them all correctly this time. So now we are looking for a confidence interval. If we are talking about the mean, what's our variable, t or z? T. So we need a t interval. We're basing it off data. Everything's in L1. My confidence level was 0.95. So we get our confidence interval. Everybody get that?
So you went to the stats test,
Wait,
8.
no.
Number 8 to t
Okay.
interval. Okay. So we have to explain what this means. It means we are 95% confident the mean diameter is between these values. So, do our balls meet the standards? What mean did we want? Is 1.68 in this interval? Yes. Since 1.68 is in the interval, the balls meet the standards. If it was not in the interval, we were 95% confident it falls between these numbers, so if our null hypothesis was not, then that would be when we reject it. Is that okay? All right, number 6. The proportion of patients who visit the ER and die within the year is 0.05. So we are talking about a proportion. So the proportion is 0.05. The hospital administrator is concerned his ER has a higher percentage, so greater than. So part B, the conditions. If I'm talking about P, we check the N. So we had 250 times P times 1 minus P. We get 11.875, which is bigger than 10, so we're good. Test the hypothesis. So this time we don't have the data. We are talking about proportion, which means we need a what? A z. So where do we go? Yeah, look at your calculators. Figure out. Tell me which one to pick. Huh? Well, we don't want a t, so we don't want a t test. What happens if you go to z test? Do we have all this? Are we basing it off data or stats? Okay. Let's see. Do we have the stuff to put in? Our mean of the null was 0.05. Do I have a sigma? No. Okay, well that's not good. What else could I do? One proportion z test. Let's try that. Number 5. Though, this looks better. P of the null. So that is 0.05. The x was 17. In 250. Proportion we were testing greater than. Calculate. Okay, and then on your paper you would write down your z and p. So our alpha was 0.01. So since p is greater than alpha, what does that mean? Part D wants a 99% confidence interval for the proportion. So what am I looking for? Z and P. One proportion Z interval. Okay, it has my X and my N already. My confidence level was 0.99. Calculate. And so then you would write down your interval. And it asks us to interpret. So that means we are 99% confident. The proportion is between these numbers. What was our null hypothesis? 0.05. Okay, so what does that mean? Since 0.05 is in the interval, we fail to reject. Just like we found in part C. Are those okay? Okay, 3 more. 4 more. Okay, next one. Why is this matched pairs?
It's the same subject.
Yeah, it's one person, 2 different measurements. So that's why it's matched pairs. So when we're doing matched pairs, we always do the mean of the difference. So the null is that there is no difference. The alternative, we are testing just to see if they're equal. So we do not equal. Then how do we set this up? Okay. Make sure everyone remembers what we're doing here. So we put this data in L1 and L2. They are like ordered pairs, so you do have to go in the same order. And then, since we're dealing with matched pairs, what do we do?
L1 versus L2.
Right. You go to the third list, L1 minus L2. Okay, so now we're talking about a mean. So we do a t-test. But you need to make sure, we're basing this off the data, the mean of the null is 0, and the list, you need to switch that to L3 because we're looking at the difference. Testing not equal. Right, so you would write down your T and your P, so then what's our conclusion? Right, since the alpha was 0.05, so P is greater than alpha, we fail to reject the null. Is that one okay? Number 8. Okay, independent sampling. Independent sampling means they have nothing to do with one another. So can this be matched pairs? No. So we are just looking at two different samples. So we write that as the mean of the first equals the mean of the second. Alternative, we want to see if the first set has a higher mean. So the mean of the first is greater than the mean of the second. All right, so if we go to test it, this time we have two totally different samples. So what do we go to? Two sample t-tests. We're dealing with the mean, so we have to do t's. We have two different samples. We are basing it off stats because I did not give you the original data. Mean of the first set, 48.2. Standard deviation of the first set, 8.4. Number in the first set is 45. Mean of the second, 45.2. Standard deviation of the second, 10.3. Number of the second, 41. Test greater than, not pooled, calculate. Okay, so we have our T and our P. That's the work you show me. We are testing at 0.1. So since P is less than alpha, we reject. We have enough evidence to conclude that the mean of the first is higher. Part C, I asked for a 96% confidence interval for the difference in the means. So what do we go to? Two sample T interval. Okay, basing off stats, it already has everything that we entered. And we are going to change our confidence level. Confidence level 0.96. Pooled, we always set to no. And we get our. Is that off? Did I mess up? Did I enter something? Let's see. First, I put 8.7 instead of 8.4. Okay. So then we should have it. All right. Any questions on that one? Last two. Okay, I told you this was matched pairs, so you put it in your L1 and L2. The null should be the mean of the difference is 0. Alternative, we want to see if the mean of the first group is smaller, so the mean of the difference is less than 0. This one I do ask for some different things. So let's enter this and then look at how to find those. Okay, so we go L1 minus L2. And then how do we get the mean and standard deviation of the difference? If you go to calculate one variable statistics for list 3, then the mean of the difference is this number, standard deviation of the difference is that number. Everybody get that? So then we need to test the hypothesis. So we go to a t-test. For L3, we are basing this off the data. Mean of the null is 0. We are testing less than. So we have our t and we have our p. Alpha was 0.05, so since p is greater than alpha, what does that mean? Fail to reject. Then part D, a 98% confidence interval for the difference. So we are looking at a t interval, number 8, based off the data. List is L3, confidence level 0.98. Calculate. And we get that interval. Everybody okay on that one? Question number 10. Researcher wants to know if there was a difference in comprehension among students learning a computer program based on the type of manual. The data shows the exam scores after they studied. So if the sample sizes are small, what must be true about the population? Right, the original data had to be normal. So part B, the null and alternative. So the null, we have to decide, are we talking about matched pairs or not? We have the same number of data. Did I tell you anything that would make you think these scores are matched up in some way? No, it wasn't one student doing 2 different tests or anything like that. I just took students using this and students using that. So these are independent. So we do the mean of the first equals mean of the second. And we're just trying to see if there's a difference. So not equal. All right, so C, you'll enter your data in L1 and L2. And then what do we go to? Stat, test, and this one would be 2 sample, number 4, 2 sample t-test. And when you do that, you should get your t to be, and the p 0.0218. What alpha level did I give you? So, since p is less than alpha, we reject the null hypothesis. Then I said to write a sentence. So we would say there is enough evidence to conclude that there is a difference in comprehension between the 2 types of manual.